In this video, I'm going to show you how to build an Ethereum wallet step by step. We're going to create a wallet for the DAI stablecoin, which is a cryptocurrency whose price doesn't change. We can use it just like real money on the internet. So you'll learn how to use the DAI token in this tutorial, and also you'll be able to learn how to create this Ethereum wallet for any Ethereum-based cryptocurrency. So I think you're really going to enjoy this tutorial. There's a lot of value here for you. All right, so before we get into that, if you're new around here, hey, I'm Gregory from Dapp University, and on this channel, I teach you how to become a blockchain master. So if that's something that you're interested in, then click the like button down below and click subscribe. And if you want to take the next step towards mastering blockchain, then head on over to dappuniversity.com/bootcamp. So this is the wallet that we're going to build, and it's going to focus on the DAI cryptocurrency. All right, so I'll talk about that more here in a second, but just a quick preview, we'll be able to specify a recipient in this wallet, specify the amount we want to send, and then, sign the transaction and see in our history. So there you go. We can see that I previously sent 100 DAI to this address and just sent another 100 DAI while you're here watching on screen, and you can watch the amount debited here. We got this cool DAI logo. So yeah, this works just like a real world cryptocurrency wallet. All right, before we start building the project, let's just go over some quick concepts so that everyone's on the same page and we understand like what we're building. Okay, so we're going to build this Ethereum wallet that uses DAI, but really quickly, if you don't know what DAI is, so it is a cryptocurrency, all right, and it's called a stable coin, which basically means its price doesn't change. Okay, so you can see that it's pegged to the US dollar here. It's equal to about $1. There's some minor price fluctuation, but basically one DAI is $1. So that is really useful when you're using cryptocurrency on the web, because basically it means, you don't have to worry about this price, being crazy volatile and changing all the time. Okay. So that's one benefit to our wallet, is we can use this just like money on the web. So DAI is a token, which basically means that it's built on top of the Ethereum platform, okay? It doesn't run its own blockchain or anything like that. It's just powered by a smart contract, okay? So you can actually see the DAI smart contract here. I'm pretty sure this is the right one. I think, so DAI's got two versions. It's got a multi-collateral DAI and a single collateral DAI. I think this is the multi-collateral. Yeah, here it is. Yeah, DAI stablecoin. So, you can interact with it. You can look at it on a website like Etherscan. This is just a blockchain explorer. And, you can find the smart contract address for DAI. We'll keep this handy for later. And, you can see all the transactions. You can look at the code and things like that. So basically, DAI is just a smart contract that lives on the Ethereum blockchain, and it's ERC20 compatible, which basically means it's got a predictable set of functions. You can see these ERC20 token transfers. You can look at the contract here. Here's the source code for it. If you're a developer, you can read all this if you want to. Well, I assume you're a developer if you're watching this video. You can do more stuff like, read the contract. You can see, like, here's the balance of function. This is a function that we're going to use in this tutorial. There's also like a transfer function. Let's just see here. That would be under the write contract tab. All right. You can see, let's see here. Transfer right here. You just show the address and then like the amount of tokens you want to send. So I've got more videos on my channel if you want to learn more about ERC20 tokens, but basically it just means that they have a set of predictable functions that all ERC20 tokens must have in order to be compatible with like cryptocurrency wallets, which we're going to build in this tutorial, or exchanges, for example, right? It's basically a standard so everyone agrees how they work, and we're not just building currencies willy-nilly without any kind of predictable set of rules, okay? So you can see how to use the DAI stablecoin, the smart contract itself, like when you're developing other smart contracts. This is a really good guide. If I remember, I'll try to put a link to this down in the description below. But this shows you, more about the smart contract, how it works. If you want to, call it from your other smart contracts, like give you some examples here. Like maybe you wanted to build a DAI faucet where people can just claim DAI tokens. This will be like how you do it. Or let's say you wanted to accept DAI payments in another smart contract, for example. Here's a great developer guide on how to do it. Basically, all you need is a reference to the DAI token and its address, in order to use it in your applications, whether it's in the smart contract or in a client-side application like this wallet that we're going to build. That's exactly what we're going to do. We're going to create sort of our own version of DAI, like a mock version of DAI. And we're going to, take the address and we're going to send it around in our application. So I hope that makes sense. And let's go ahead and start programming. All right, before you get started programming, you need a few dependencies first. The first is NPM or Node Package Manager. So you can see if you have that already installed by going to your terminal and typing node-v. All right, if you don't have it already installed, you can install it from the Node.js website directly. I'll just pull that up here. Yeah, here it is. So basically, you can just go to the Node.js website, go to the download tab, and pick your operating system here. All right, so the next dependency is the Ganache personal blockchain. So Ganache basically is going to allow us to run a blockchain on our computer without having to, worry about spending real money or anything like that. So Ganache is pretty easy to install. You can just get on Google and look for Ganache blockchain. It should point you to a download link, and you should see this page. And you can just download the correct version for your operating system with this link right here. And then once you've got that installed, go ahead and boot Ganache up. It'll ask you probably if you want to create a new project or quick start. I always do quick start. And once you've clicked that, you'll see your blockchain running just like this, all right? So it's got some accounts here already, with some private keys, which you can see here. So don't use this account on the real Ethereum network because you might lose your money. But you'll see, some money already in these accounts. This is just fake money for development purposes. But yeah, that's how it works. And I've already used this account, so I've lost a little bit of ether already, but that's okay. So that's what you need for dependencies. Now let's go ahead and create the code for the project. All right. Oh, sorry, one last dependency. You need MetaMask, okay? So this is an Ethereum wallet that's going to allow us to interact with the application. So MetaMask is pretty easy to install. You can just Google how to install MetaMask, and it should take you to a page like this. And you can just click Get Chrome Extension, or you can search for it in the Chrome Web Store. And you can just find it and then just click Add to Chrome. Once it's added to Chrome, just make sure it's activated, and you should see the Fox icon here. It'll prompt you to set it up with a password and everything. Just follow those steps. It's pretty straightforward. And I'll show you how to use MetaMask more in this tutorial. Okay, so now that the dependencies are actually installed, let's go ahead and create the project. So in order to get started really fast, I'm going to use a project template that I've created on my own. This is my starter kit. So this is going to allow us to create the project without setting everything up step by step. It'll save a lot of time, and it'll make the tutorial just easier to follow. Okay, so you can create your new project with this template just like this. Just say git clone, paste in the URL here, and I'm going to call this project ETH wallet. All right, and that should create the new project like this, and then you can enter into that newly created directory like this, cd ETH wallet. All right, and I'm going to go ahead and open this project in my text editor, which I'm using Sublime Text, and this is how I open it in my terminal. I've got this configured as a special symlink. So here you go. Here's the project. This is what we just created. This is a truffle project, which is a smart contract development framework used for building blockchain-based applications. You've got a configuration file here that's already done for you. You've got a package.json file here with all of your packages. So yeah, we've got everything that we need. We've also got a React application inside of here. We can go to the source directory and components and look at the app.js file. Right, this is where we're going to put all the code for the React application. So yeah, we've got everything wired up for us already. All right, so let's go ahead and install the project dependencies. We've got pretty much everything installed here with the package.json file. But I'm going to go ahead and kind of just do a smoke test to make sure everything's set up properly. Let's do that first. We'll say npm install. All right, and that should go ahead and install the initial packages that we've specified here in our package.json file, but we will want to install a second dependency, or an additional dependency, here in a minute. All right, so it looks like that worked just fine. So I want to install one more dependency here, which is Open Zeppelin library. All right, so basically this is a library of pre-made smart contracts that we're going to use for this tutorial, okay? We're not going to have to write a bunch of smart contract code. Really all we're doing is creating a fake DAI token or a mock DAI token that we can use in our tutorial to make things a lot easier. We can do everything on our computer. So I'm going to install Open Zeppelin like this. All right. So just paste this, npm install open zeppelin contracts. This is going to give us basically a way to create a token really quickly. So if you look at the contracts in here, I'll show you this while it's installing. You can go to contracts, and then let's see here. Let's go to token. All right. And then we can go to ERC20, which is what DAI is, an ERC20 token. And it's a pretty complex ERC20 token. It's got some extra functionality than a basic ERC20 token. But basically, what we'll do is create a mock DAI token with this smart contract already included for us, basically, we're just going to create this mintable token. So here it is. Here's the ERC20 mintable token. It's got a mint function. It's just going to allow us to create tokens on the fly. And I believe the DAI token also is mintable as well. So it'll work very similar, but it won't have all the features that DAI has. It's just basically a mock so that we can understand how to use DAI in our application. I'm going to create the new smart contract just like this. I'm going to go to the, let's see here, the source. All right, contracts directory. And you can see you've got a file in here already. I'm going to create a new one like this. All right, I'm going to call this DAI token mock.sol. And inside this file is where we're going to make our fake DAI token. All right, so a mock in software development is something that really just stands in place of something else. So in this case, this is going to stand in place of the DAI token. So it's going to work like it. It's not going to have all the same features, but we'll see how to use it. So basically, I'm going to declare the version of the Solidity programming language that we want to use like this. Just say pragma solidity, and then pass in this version 0.5.0. And then the next thing I want to do is declare the smart contract like this. All right, I want to say contract DAI token mock. All right, and then I want to use these curly braces, and we're going to put all of the code for it inside of the curly braces here. So we won't write much code in this tutorial. We're just going to get it up and running with this Open Zeppelin library. So I'm going to import it like this. All right, we're going to create a mintable token. I'm going to paste in the import like this. All right. So we're going to go from the Open Zeppelin library. We're going to pull in the contracts, token, ERC20, ERC20 mintable. And what we're going to do is say the DAI token mock is ERC20 mintable. Okay. And then we're going to configure this. DAI has a name, a symbol, and decimals. So, we're going to create that in our contract like this. Basically, we're just going to create some variables to give it a name, the symbol, and the decimals. All right. So in Solidity, it's statically typed. So we have to tell it that the name is a string. We have to tell it the symbol is a string, and that the decimal resolution is an unsigned integer. All right. And we use public for all these so that we can read these values outside the smart contract. So lastly, what we need to do inside of here is create a constructor function, which is the function that gets run whenever the smart contract is created or deployed. It's run once and only once. And we just create the constructor keyword like this and set all the variable values like this. Boom. All right. So here's a constructor function. It's public. This will get run whenever the smart contract's created. We'll set the name as DAI stablecoin. All right. Just like we saw here on Etherscan. I'm actually using these values verbatim. So if you go here, it just says DAI stablecoin, all right? And the symbol is DAI, and the decimal resolution is 18, which is just like Ether. So basically, if you're wondering about decimals, it's like how many zeros are behind the decimal. So for the US dollar, for example, it's 2 decimal places, but for like Ether, it's like 18. And so for most ERC20 tokens, it's also 18. That should be our smart contract. Let's go ahead and compile it, see if it works. Say truffle compile. All right, and let's make sure we have Ganache running before we try to deploy it. All right, so make sure you got Ganache running just like this. Okay, awesome. So it compiled with no problems. So make sure you can pass this step before you continue. And the next thing I want to do is put it on the blockchain so that we can use it. So I'll do that like this. I'm going to go to, let's see here, migrations. And you'll see this initial migrations file. And I'm going to add the DAI token just like this. I'm going to copy this line and come down one. Oops, sorry. Wrong copy. Copy, paste. All right. And we're going to get the DAI token mock that we just created. DAI token mock. Okay, so Truffle exposes these things called artifacts, which we can, read just like this. So we had a DAI token mock here, which is in the same, revealed in the sidebar. Yeah, we can see we had a migrations contract in here, and now we have the DAI token mock. So basically, this was already there for us, and then Truffle also exposes this, just like it did migrations. And now we can put the smart contract on the blockchain inside this function, just like the migrations contract, okay? So I'm gonna modify this a little bit. I'm gonna use the async await pattern. Basically, this is a way of handling asynchronous function calls in JavaScript. We can wait for them to finish. So I'm going to say await deployer.deploy migrations. And then I'm going to deploy the DAI token mock next. All right, paste this in here. And then I'm finally going to actually mint some tokens for the deployer inside of here so that we can, actually have some tokens to use in the tutorial, okay? So I can do that just like this. I'm gonna get a copy of the deployed token. I'll say just const token mock equals await DAI token mock.deployed. And then I'm going to basically mint 1,000 tokens for the deployer by calling the mint function, all right? I can use this async await pattern to do that like this, all right? Boom, okay? So await token mock, we're gonna call the mint function, and I'm actually passing in the account address here that I used inside Ganache. So you can just copy this from your Ganache instance and paste it inside of here. All right, just like that. And then I'm using 1,000 tokens. So I'll show you how to do that. A minute ago, I talked about how DAI has 18 decimal places. So basically, you need to write out the number 1,000 and use 18 decimals, or 18 zeros after that. Now, you could do this with a helper with Web3.js or something like that, but sometimes in like migrations, I'd try to be explicit just so that everything is, straightforward. So you can say 1,000. So 1, 2, 3. All right, that's 1,000. And then you have to actually type 18 zeros. But if you know how to use Web3.js or you want to like write this out programmatically, that's fine too. I'm just being explicit for tutorial purposes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 is 1,000 tokens. All right. So now let's deploy this to the blockchain like this. We'll say truffle migrate. All right. And that will put it on Ganache for us if there's no problems. Okay, there we go, done. So no issues. We've deployed our mock DAI token to the blockchain. So now let's go ahead and open up the website and create the Ethereum wallet. So I'll say npm run start. All right, this will open up the client-side application, the React app, inside our browser here. So this was the old version that I already created. We're going to refresh this and see what you should actually have whenever you open up your project. So there you go. This is the Dapp University Starter Kit. This is the website that came for free whenever we used this project template here. All right, so what we're going to do is modify this code to build that Ethereum wallet that I just flashed upon the screen, okay? So there's several steps that we need to do in order to make that happen, but we've got all our back end done. It's really good. The smart contracts on the blockchain, all we need to do is connect this client-side application to the blockchain, pull the smart contract in, and work with it to build the wallet, create the transactions, show the transaction history, show the balance. So it's a few steps, but let's go ahead and get started. So go ahead and head over to your source directory and then go to the components directory, find the app.js, all right? So here's where all the code is. You can see Dapp University Starter Kit. It's the same text as you see here. That's where all the code is. We're just going to modify this. So what we can do is, just change this up and add all our code to the connect to the blockchain here, all right? So that's exactly what I'm going to do first. The first thing I'm going to do is connect to the blockchain, all right? And so you can see, if you're not familiar with React, really quickly, I'll just give you an explanation. This is a React component. This is the React class. This is how it works. You put all the components inside these classes. They're just these reusable, modules of code that have JavaScript and HTML mixed in, and that's what we'll do. And then we'll also use the React state object to act like a database on the front end where we can, fetch information and store information inside of it as well. So you'll see all that in action here pretty quickly. So really quickly, I'm just going to recap that again in case you all didn't understand or if you're new to React. I want to give you a quick primer because I don't want you to feel lost. So again, React is a JavaScript library for building user interfaces. It's component-based. You can see this is what a React component looks like. That's what I just showed you. It's got this return function that has HTML code inside of it, mixed in with JavaScript. This is all JavaScript. This is HTML. And then you can put JavaScript back inside here of your HTML like this, okay? So you can add more functions than just that render function. Like you can see a constructor function here. Here's this custom tick function, which will create something kind of like that in this video. It has these life cycle methods like component did mount, which get called whenever the React component's mounted to the virtual DOM, which will create one of these as well. So yeah, that's how it works. And then finally, here's the state object. So you can see this here. Basically, this is how React manages its data. It uses this state. So we can add items, just like you would in a to-do list here. How does this to-do list know how many items are on the list? Well, it uses this state object, right? It shows you what the items are. It shows you the text for what somebody's added here. So yeah, that's what we're going to make use of in this tutorial. So that's a quick primer on React. All right. So back to coding. Let's go ahead and create one of these lifecycle methods that I just talked about earlier to connect to the blockchain. You can see here this component did mount. We're going to create something like this, all right? But we're going to call it component will mount. So I'll just copy this from React, put it inside of here. All right, this will say component will mount. And what we're going to do is say await this load Web3. Okay, we're going to create a new function that's going to connect to the blockchain. So what does that mean? Well, basically, this application doesn't connect to the blockchain by default. We have to create a way for it to do that. So we use the Web3 library, basically as a JavaScript library that will turn our application into a blockchain application. So we import it into our project just like this, all right? And then we can create a function to load Web3 just like this, all right? So I'm going to do a little bit of magic here, paste in some code. Don't worry if you don't understand everything that's going on here. I'll explain kind of high level what this is. So basically, this loads the Web3 connection, which basically means it connects the application to the blockchain. And honestly, this is just kind of modified code that is specified inside the MetaMask documentation on how to connect your app to the blockchain. MetaMask is the Ethereum wallet provider that we're using here. And basically, MetaMask provides a way to connect to Ethereum, and this is essentially their instructions. So don't worry if you don't understand everything that's going on inside of here. You can read through the documentation if you want a greater understanding, but this is just a quick implementation on how to wire this up to the blockchain. So that's kind of just done for you. And you can copy and paste this out of the completed tutorial code, which I'll put a link to down in the description below. All right, so we've loaded Web3. Now the next thing we want to do is load blockchain data. So we'll say await this load blockchain data, just like we did load Web3. All right, and this is where we'll create a new function to connect to the smart contract, get the balance, allow us to create transactions and things like that. All right, so here's our new function where we'll load the blockchain data. And basically what we want to do inside of here is first just get a connection to Web3 like this, all right? So we done load blockchain data, and we say this Web3 equals window.web3. So what I want to do now is console log this and just say Web3 and make sure that everything is wired up properly, all right? So let's go back to our website, and we can already see we've got some errors here. So what's going on here? Await is not working. So that means we haven't properly done the async await pattern, I believe, all right? So that's because we didn't do it here, async. We forgot the async keyword in front of component will mount. So I fixed that. Let's go back to our project, refresh. And let's see if there's any more errors. All right, there we go. So we can see the content. Let's open the dev console here. You can do inspect element if you want to by right clicking. I use some command that's involving an I. I just do it from memory. I can't actually remember what the command is. But anyways, we can see Web3 has been logged to the console here. All right, so it's been successfully set up. All right. And what you want to do now is go ahead and install or go ahead and import the accounts from MetaMask. Okay. So what I would do is open Ganache. All right. We're going to get the first 2 accounts. So show the private keys. All right. Right here. Don't actually use these private keys in real world. Just use them for development purposes. Copy them. And you're going to want to do this step twice. All right. For this account right here. And then also this account. All right. So go ahead and grab the first one. Go to MetaMask, open your account. I've already imported it, but basically you'll want to go to import account, paste the private key, and click import. All right. So you want to do that for both accounts, which I've already done because you can see my account here. And you want to, do it for this one and then do it for this one to where you can have access to each account. All right. And just remember which one it is whenever you add them to MetaMask, because we're going to switch back and forth here in a minute. Okay. Now what we'll do is actually fetch that account out of your MetaMask wallet and show that in the console, okay? So I can load the account up from Web3 just like this. All right, I'll go back to Sublime Text here. And instead of console logging Web3, what we'll do is console log the account, all right? So I can get the account just like this, say accounts equals Web3, await Web3 ETH, I get accounts. All right, and what I can do is console log accounts, just like this, so you can see what's in there. All right, boom, there you go. So there's your accounts that are provided from MetaMask. All right, that should match whatever's in Ganache if you've selected the account correctly. All right, AEC. So we can see this is an array, and we just want to fetch the first one, so we can add it like this. We just say this set state, and we say account equals accounts. All right, and then we just get the first one from the array like this. We just use these brackets and pass in 0 because 0 refers to the first item in the list, okay? And so state here is, we're updating this React state object, which I showed you a minute ago here. Let's see here. Yeah, we see this, state equals this. Or we can do set state, all right, just like this, where we pass in a function and we, say the key and then the value. Okay, so the key here is going to be account, and then there's the accounts. So now what I want to do is configure the default state inside of React. So you can see that here. They show you an example. Use this constructor function, all right? And basically what it does is it sets a default state, and we will modify this for our own purposes to show you all the data that we're going to load up in our app. So in their example, they use a to-do list, so it's got items and text, all right? But I want to add more things to this, all right? I'm going to kill this. Instead of items, we're going to add, our Ethereum account, and we're going to add stuff like transactions and our balance and all that kind of stuff, right? Reference to the smart contract. So I'll do that just like this, all right? So instead of what they have here, I'm going to make our default state look like this, okay? So we'll store the account, we'll store the DAI token mock smart contract, we'll store the user's balance, and then we'll also get their entire transaction history and add them to the state as well. So here's our defaults, okay? So we can continue filling this out. We've loaded up the state, we've set the account. The next thing we want to do is actually get the DAI token, okay? So what I want to do is find it inside of our ABIs. So go to source, let's see here, ABIs, and we can see our DAI token mock here. All right, scroll all the way down. This will show you the address of where it's located on the blockchain. So copy this address and put it here. All right, so we'll say const DAI token address. All right. Place DAI address here. And then also the DAI ABIs we need next. So we can import it into our project like this. I'm going to go here and say DAI token mock. All right. So I just imported the ABIs file, ABIs DAI token mock.json. That's this right here. This is what was created whenever we compiled the smart contract with Truffle. Okay. So that's what we need. We need the ABI and we need the address in order to create a Web3 version or a JavaScript version of the smart contract so that we can call its functions in JavaScript. Okay. So now let me make a quick mention. I'm doing this in development with this mock here that we've created. Okay. I just created a test version of this so that you can play around with it on your computer. you could use this in the real world with the real blockchain by using the real DAI address that I showed you here, right? You can just get the smart contract ABI for this, the actual smart contract, like which is right here. You can just copy this and put it in your app, right? And then go find the actual ABI as well, right? You can find the information here. Yeah, if you go to code, you can find the ABI here, right? So you could just pull this into your app in order to actually use the real DAI token. But I'm going to continue on with the test version in this case, just so that we can, know exactly what's going on. We can use Ganache. We don't have to risk real cryptocurrency. We don't have to get test cryptocurrency on a test blockchain. This is everything you need right here. Okay, so I'm going to create an instance of the DAI token with Web3 just like this. All right, I'm going to say DAI token mock equals new Web3 ETH contract. All right, this is how you do it in Web3. You create a new contract like this, and then you pass in two pieces of information. The ABI, right, which is this DAI token mock, which we just imported here, and then the address, which I have pasted in here. And like I said, this will be different for you. You got to find it from your file. Or you could use the actual DAI token if you want to connect to a test network and you have test ether or the main net for that matter. Okay. So, yeah, there we go. And then next, what I want to do is add it to the state, just like this. All right. This dot set state DAI token mock equals DAI token mock. All right. You could do this shorthand with ES6 like this, but I'm going to keep it explicit for now so that everyone's on the same page. All right. And now what I want to do is just console log this state DAI token mock. Save that. Go back to our page and let's just make sure everything's still working properly. All right, there we go. There's the DAI token mock. All right. Okay, so next let's keep loading up the blockchain data. What I want to do is get the balance. Okay, so here's the balance is 0. We want to show the user's balance on the page. So we can call the balance of method on the ERC20 token just like this. Oops, sorry. I kind of got lost here for a second, guys. My apologies. We'll say it like this. Say const balance equals await DAI token mock. We use methods, and then we say balance of. All right, that's the function that's used on the smart contract itself with the ERC20 token. This is an ERC20 function. And then we pass in the account. That's the account we want to read the balance of. This .state.account, which we just set here. We pulled this from MetaMask, and we're showing the current user's DAI balance, okay? And then we can't just call the function yet. We actually have to say .call, okay? And we can read that information from the blockchain when we do this, okay? So let's do this, and then we'll console log balance. Boom, there we go. Awesome. So it's working. And you can see this is a big number that's got a hex. So what we can do is say toString. And boom, there we go. So here's your DAI token balance. All right. And as you can see, it's this huge number with a bunch of zeros after it. This is the same number we did here. All right. But it's only 1,000 DAI tokens. All right. And that's because it's got 18 zeros behind the 3 zeros that represent 1,000. So now what we can do is basically show you how to convert this to a human readable number. I can do this. I can use a utility provided by Web3. So let's say window.web3, all right, which is right here. Or we can just do this since we've got access to it. Web3.utils, and then do from way, all right? And then we can say ether, all right? And then do another, oops, sorry. Basically what this does is this is a utility for converting ether to way. So way is the smallest denomination of ether, kind of like a penny. And it's the same for the DAI tokens. Basically, DAI has a really small penny, so to speak, that has 18 decimal places behind it, just like ether. So we can use the same helpers to convert DAI to its own, bigger denomination, just like we can ether to way. All right, so we can use this function to convert it. All right, so there you go. Boom. Now we can see the balance is actually 1,000 and not like a bajillion. So now what I want to do is update the state. update that balance here. All right. So we'll just say, you know, this set state, and then we'll pass in balance, and then we'll do this here. I think I got that right. I don't think there should be any errors. Let's look on our screen. All right, so it's not in the console anymore. That's okay. I removed the console logging statement. But yeah, there you go. So next what I'm going to do is get the final piece of data from the blockchain, which is the user's transaction history. Okay, so basically what we're going to do is get the past events or the event stream from a smart contract. Okay, so I'll show you what I mean by that. So smart contract, actually, I'm sorry, I'm pulling something off screen here. ERC20 transfer event. So basically, all ERC20 tokens must implement this thing called a transfer function, right? When that's, we're going to see that here in action here in a minute. But basically, like, that function also must emit an event. So you'll see here, like, here's a basic ERC20 token transfer. Okay. So this basically calls a transfer function, but what it also does is it triggers an event. And basically what events do is they emit messages that consumers can subscribe to know that something happened on the blockchain. And in this case, basically it's going to know that cryptocurrency was sent from one person to another. And the cool thing about events is you can get the entire history of all the events that were ever created. Okay, so we can get a event stream. All right, so we can find all the transfer events that ever happened, and we can also find the ones that just pertain to us. So we can do that like this. We can say const transactions equals await DAI token mock dot get past events. All right, and I'm going to get all the transfer events. And what I'm going to do is say from block 0 to block latest. So it's going to look in the entire blockchain. All right. And then finally, I'm going to filter these events so that we only get the ones that pertain to us. All right. So I'll say from, this will be at least all of the transactions that we sent. All right. I won't show the ones we received. I can leave that to you as an exercise, but we'll at least be able to see all of our outgoing transactions. So say from this.state.count. All right. And that should be everything. All right. Yeah. Awesome. So let's say console log transactions. And it probably won't show anything yet because we haven't sent any. But let's see here. All right, so we got a problem here. I think I made a typo. All right, forgot to capitalize this. DAI token mock. All right, so this callback is not a function. So we got a little bit of an issue here. Let's just see if we can fix it. All right, so it looks like I had a little typo here, but it's all fixed up now. Okay, I forgot a extra curly brace here. So yeah, there we go. So we can see that the events were logged and it's got no events yet, which is expected because we haven't sent any outgoing transactions yet, right? But if I like clear this filter, you'll be able to see that there is an event. All right. So boom, here it is. This is when we minted the tokens. We can see an actual transfer function was called. Okay. So I'm going to put this filter back in and we'll see this more in action later. All right. So save that. All right, so that should be all the data that we need from the blockchain itself. I'm going to leave this console logging statement in here so we can inspect the transactions. But what I want to do now is start laying some of this content out on the page, actually update the UI and build out our Ethereum wallet. Okay, so I'm going to kind of make this smaller here. Well, I'll do that in a second. First, what I want to do is replace this logo. All right, so instead of the logo that we have here, I want to put the DAI logo. So I'm just going to like get on CoinMarketCap and take their logo off there. So if anybody's watching this from CoinMarketCap, my apologies. I'm not trying to plagiarize anybody. This is just for tutorial purposes. so that people can learn how to build blockchain programming. If you have any issues with this, just reach out to me at Gregory at dappuniversity.com, but I don't think you'll mind. Okay, so I'm just going to save this, put it in the project. I'm going to resize it in my downloads folder, and I'll pop it in here. If you want to take the image from my repo, you can do that. It'll probably save you some time. All right, so I've pulled this into my project here. You can see that here's the logo, and then here's the DAI logo. All right, so I'm just going to replace what we have inside of here. Where's my logo? Let's see here. So we'll say DAI logo, and then we'll replace this. Let's say DAI logo. All right, we'll say DAI dash logo. Save that. Go back to page. All right, there we go. It's a big old DAI logo. So let's resize it. Let's see here. We'll just remove this. And we'll say width. We'll say 150. All right, there we go. Make it a lot smaller. And then next what we'll do is say, let's actually put the balance, okay? We can add the balance like this. Let's just clear this out. We're going to execute JavaScript inside of here. So we'll use these curly braces. Oops, sorry. Uh-oh. Everything's kind of going haywire here, guys. We'll say this state balance, and then we'll say DAI. All right, let's go back to the page here. Boom, there we go. Awesome. Done and done. All right, so next we want to do is create a form that will send DAI. So we'll be able to specify recipient and also the amount. All right. So what I'm going to do is just copy and paste in some boilerplate code so that you can see how this form works. All right. So I've added some basic code here for the form. All right. So this is just a form HTML element. And I've got this onSubmit handler here with a function that we'll fill out here in a minute. All right. So say to do handle submit. All right. And then I've got a button here that will actually do the submission. Okay. So basically here's the submit button. Whenever this is clicked for sending tokens, we'll actually send the tokens here. So all you can see right now is a send button. All right. It doesn't do anything yet. We also need to be able to specify, where it's going to. So the first thing we'll do is add a recipient just like this. All right. I've created an input for the form. All right, and then what we'll do is use these things in React called refs. So whenever we fill this out, it's going to store the value here for the input. All right, this will be the recipient. And it'll just have a placeholder of recipient address. So we can see that here, recipient address. And then what we want to do is also, just like that, just like the recipient, we want to specify the amount. So I'll add a new field here like this. All right, so here's the amount. Go back to page, all right, address and amount, okay. So now I want to clean up our UI a little bit and create a width, okay. So on this very top element here, just below main, I'm going to say style equals width 600 pixels, all right, just like that. Save it, go back here, all right, yep, there we go. We can make it a little narrower even since it's a wallet. Let's say like 500. Save. Let's do even a little less. Let's do 400. Just a wallet. We don't need a lot of space. Boom. There we go. Awesome. That looks nice and clean. So now let's wire this up. Okay. Whenever they click the submit button, the first thing we want to do is, prevent the default behavior. We don't want the page to refresh. So there we go. And then we'll track the recipient. All right. Like this. We'll say recipient equals this dot recipient dot value. That's what we did here. All right. And then next what we want to do is get the amount. We'll say const amount equals this dot amount dot value. All right. And then we'll just console log those. Let's see here, recipient, amount. Refresh the page, go back here, and let's just put in somebody's address. Let's copy this address here from Ganache, the second one. Oops, sorry. Put in the recipient, the amount. Let's do 100 DAI tokens. Click send. And here you go. Here's the recipient, and here's the amount logged to the console. All right. So now what we want to do is format this. Because we're sending DAI, we don't want to just send, 1,000. We actually have to convert it to its decimal resolution, which is 18. So here, we converted it from the decimal resolution with Web3.utils from way. So we'll do it kind of similarly. Basically, we'll just copy this and then paste it here. Amount. All right, so instead of from way, we want to do to way. All right, and then say value ether. So I'll show you what that looks like in the terminal. So it's window.web3. All right, and then put in the recipient address again. Oh, sorry, let's just copy it from Ganache. So say 10 DAI tokens, and 10 looks like this. Okay, when we convert it, and that's what we want. All right, so the last thing we want to do is actually call this in the smart contract to send the cryptocurrency, okay? So let's do that. Let's create a function where we're going to interact with the smart contract. We'll just create a transfer function right here. All right, we'll say transfer, and then we say recipient, and then amount, because those are the two arguments for the ERC20 function transfer. We'll say this.state.DAI token mock methods transfer. And we'll pass in recipient and then amount. All right. And then finally, we have to call send on this. We can't just call the function by itself. We actually have to trigger it. And then when we call send, we must tell who is sending it. So either from, we say this.state.account. This.state.account, because they must sign this transaction with MetaMask and finalize it on the blockchain that way. All right, so that's all we have to do here. Actually, there's one more step. We need to bind it here like this. Boom. This transfer equals this transfer bind this. All right. So now inside this form submission, we can call that function just like this. Pretty simple. Basically, we'll change this and do this. This.transfer, pass in recipient and amount, and it will call this function and talk to the smart contract, provided that we wired everything up correctly, but that's the idea. So let's paste in the recipient address. Sorry, let's copy it again from Ganache. Let's actually send 100 DAI tokens this time. All right, let's click send, and you should see a MetaMask confirmation pop up. All right, it's even telling you that you're sending 100 DAI, which is pretty cool, plus the fee. Click confirm, refresh the page, and boom, there you go. Your DAI balance went down by 100 tokens. So now let's build out the final feature where we actually show our transactions at the bottom, our transaction history, okay? So, now that we've logged these out to the console, we can see that we actually have some transactions now. And what we want to do is basically dig into each one of these transactions, find the return values, and then pass those into the table. So we want to show who the transaction went to, and then also the amount, which is going to be stored here in the value. So basically to and then value. That's what we're going to show on the screen. Who you sent money to and then how much, okay? So we're just going to create a basic table like this. All right, I'll just copy this and paste it in here. Let's see. Table after the form, we'll do this. All right, so table, it's going to have a header that's going to have the recipient and the value. All right, and it's going to have a body. All right, so save that. And it looks like we're missing one more tag, closing tag, body, or table, sorry. Table tag wasn't closed. All right, so let's go back to the screen here. All right, boom, there we go. So recipient and value are the two things that we want to show. And we can fill this out like this. Basically, we're just going to map over all these. Say this.state. .transactions map. All right, and we'll pass in a function. Basically, this will be the transaction and then the index. All right, and then we will display them out on the page like this. Basically, we'll say return, and then we'll pass in tr equal or like this. And we'll say td. All right, and we'll start with the tx return values, and 2. All right, that's going to be who the transaction went to. And then we'll also do the same for the value, okay? We'll say toString, because it'll blow up on us if we don't, okay? All right, so the last thing is React needs a key here, because all these elements need to be unique on the React virtual DOM. So we're just going to use the index as a unique key. All right, so that's just a weird React thing. Don't worry if you don't totally understand why we did that. That's okay. All right, so looks like I need to put this inside the table body as well. Sorry, guys. Let me just come down here. All right, let's refresh the page like this. And all right, there we go. So we should see something here. Let's make sure I got all this right. All right, so I just realized we never actually put the transactions in the state. So we'll do that like this. All right, we'll just do, instead of console log, we'll do this set state, so transactions. All right, we'll just pass in the transactions here. All right, clear that out. Transactions, all right. So we'll see, all right, boom, there we go, awesome. So here are the transactions logged out to the page. All right, we got some overflow going on here. We can fix all that, don't worry. But let's do one other thing first, okay? So instead of just showing out, you know, this crazy big number, we want to show a human readable version of this. So let's do this. Instead of, you know, just showing the raw value, let's convert it to its human readable value with the same helper that we used up here when we showed the balance. We'll use Web3 utils from way. All right, we'll do it just like this. Boom. So window.web3 utils from way, transaction return values, value, toString, and we'll convert it to ether. All right, so boom, there you go. Awesome. So this recipient's kind of big, so it may not take our specified width here. So maybe we should bump this up to, let's do 500 pixels. All right, there we go. So 500 pixels seems to be an appropriate width that will accommodate all this. One alternative is we could truncate this, but for now, let's just show everything explicitly on screen. Okay, so that's it. You have now created your own Ethereum wallet with the DAI stablecoin. So congratulations. This is a really amazing app that uses a real world currency, or at least a fake version of it. But you could very easily use the real DAI token by replacing this address, by using the actual DAI token ABI, which you can find here on Etherscan. Explained all that in this tutorial. That's a way that you can level this thing up to be a real world application. All right. So if y'all like this video, again, the source code's down in the description below. As always, subscribe to the channel, click the like button down below. It really helps these videos get found so that more people can benefit from them. And if you want to take that next step to mastering blockchain, then head on over to dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.